Hello, welcome to all. My name is Deepak Bhatta. I am from Kailali Multiple Campus, Assistant Professor. Today we will discuss the important questions on discrete structures. The question is define transport network, explain flow, slack of edge, saturated and unsaturated edge, F augmenting edge, F augmenting path, and S to D cut. And also calculate slack of each edges, write down saturated and unsaturated edge, and find S to D cuts using following graphs. So in the given questions we have to define the transport network. Then after you also need to explain the flow, slack of edge, saturated and unsaturated edge, and F augmenting path. Also you need to explain the S to D cut. And from the given graph you need to calculate the slack of each edges and find out the saturated edge and unsaturated edge from the given graph, and also find the S to D cuts using the given graph. So let us discuss what is transport network. So basically a transport network is a flow network, is a directed graph where each edge has a capacity and each edge receives a flow. The network involves nodes and directed edge where nodes represents the vertices and edge represents the arcs. So nodes represents points such as intersections or junctions. Edge represents path or routes between these points, each with a specified capacity indicating the maximum flow it can handle. So the given graph is in directed graph. So the directed graph has the following properties. So the first property of a directed graph is a graph G has exactly one source node. Source node means that node which do not have any indegree, means that the node which has 0 indegree is known as a source node. And we also have exactly one sink node. Sink represents the destination of the graph. Simply we can call this sink node as a destination of the graph. So the total number of out degree of the node is also 0. So in the given graph we must have only one source node and only one sink node. So I will show you an example. What does it mean? So if I assume this A is a starting node or a source node, means we do not have any incoming edge on it. If this node has incoming edge, then I cannot call this node as a source node. So remove it. So let us assume this B as a another node, and there will be C, and there will be D, and there will be E. So let us make a direct path. See, so I have just created A, B, C, D and E as a nodes in this graph. So this node represents we do not have any incoming edges, we just have outgoing edges. So we can call this node as a source node. So we can call this as a source node. we can call it as a source node. Source node. Okay, so this this C, observe this C, we have this incoming edges and we also have this outgoing edges, so this cannot be called neither your source nor your sink node or destination node. So this is a intermediate node of this graph. So here B is also intermediate node, neither your source node nor your sink or destination node. So this also D also has incoming and outgoing, so this D cannot be called as sink or source node. So observe this E. So observe this E have only incoming edges. So as per the definition, out degree must be 0. So here we do not have any out degree, so out degree equals to 0. So we can call this node as a sink node or destination node. So here this A node no any incoming edge, so no any incoming edge, that is 0. So we can call it as a source node and E as a sink node or destination node. So first of all we need to identify which node is source node and which node is our destination node or sink node. So now let us discuss the third property of the directed graph, that is each edge E of G has positive capacity. So we have the capacity and flow of this node from A to C. So you must have the positive capacity, means that you can have 6, you can have 5, you can have 4, you can have 2, you can have 3, you can have 2, not -1. So it will neglect the -1, so you cannot assign the edge of the capacity of the edge as a negative value. So only always assigns the positive capacity only, so negative part will not be included or used in the transport network. So let us remove these things. Okay. Okay, now as far we have discussed the concept of transport network, so you will write these things if question asks this define transport network, you will have to write down these definitions along with the property of the directed graph. So now let us move on to the next part of the question. Explain flow, slack of edge, saturated and unsaturated edge, F augmenting path, and S2 D cut. So let us jump on to the next part of the question, that is flow. So you need to explain this flow as the flow is the amount of commodities such as data, water, traffic, etc. passing through an edge from one node to another node. So here is the example. So we have a S and source and A as an intermediate node and C as an intermediate node. So if I want to move from S to A, from source to this intermediate node, I have given some flow. So from the flow, I need to move or pass from source to destination. So the definition as flow, the flow is the amount of commodities such as data, water, traffic, etc. passing through an edge from one node to another. So key points to be remember for the flow definition: the flow on an edge cannot exceed its capacity. For any node other than the source and the sink, the total flow into the node must equal the total flow out of the node. So it tells that our flow on an edge cannot exceed its capacity. So in the given question, we can determine or we can find out which one is flow and which one is capacity. So this 5 is a capacity, this 5 is a capacity, and this 3 is a flow. So likewise from S to C edge, 4 is a capacity, and this 3 as a flow. All right, so you need to find or determine which one is capacity and which one is flow from the given diagram. So here the below definition tells you that the flow on an edge cannot exceed its capacity. So this capacity value must be greater than the flow value. So you can observe in every edge of this given graph. So S to A, we have a 5 and 3 is a flow and 5 is a capacity. So 5 is greater than 3. Likewise we have S to C. In this edge we have 4 and 3. 4 is a capacity and 3 is a flow. So 4 is greater than 3. Likewise C to A, 5 is greater than 1, or A to D, 6 is greater than 1, and B to D we have 4 is greater than 3. So one thing to be noticed that we can have the same value, capacity and flow. So capacity of an edge greater than equals to flow of an edge. So we can tell that we can have the same capacity value and same flow value, but not this 2, 3. So we do not have the value like 2, 3. This is your capacity. All right, this is your flow. So always capacity value is greater than equals to flow value. So this 2 is our capacity and 3 is value. It cannot be possible. We cannot pass the capacity over value. Okay, so this capacity must be greater than that. If I write this it as a 4, then it is possible. We can pass or we can flow from this edge. All right. So you must keep in mind that capacity, which one is capacity and which one is flow. Okay. So move on to the next topic, that is slack of edge. So slack also represents the residual capacity of the graph. So slack of an edge is the difference between the edge capacity and the current flow on that edge. So we have a formula that slack equals to capacity minus flow. So in the above graph we have a capacity and flow. We already discussed. First thing first, we need to determine which one is capacity and which one is flow. So after that, we need to calculate the slack of an every edge using the formula, that is slack equals to capacity minus flow. That means if I want to find the slack of edge, that is S to A, then capacity of S to A is 5 and flow of S to A is 3. Then the slack of S to A is will be 2. So this is slack. So slack of edge, that is S to A. Likewise, you can find every edge slack in the given question. So later on we will find out every edge, each and every edge of slack value. So don't worry, we will calculate further. Okay. So it indicates how much additional flow can be pushed through the edge before reaching its capacity. So in the given question, you need to write the definition of slack along with the formula. Then move on to the saturated and unsaturated edge. Saturated edge means then an edge is a saturated if the flow on its equal its capacity, that is it is no remaining capacity for additional flow. Means let us assume that saturated of an edge, that is flow of an edge which is equals to capacity of an edge. So saturated edge means flow of edge equals to with the capacity of an edge. So in the given question, if you have both A as a node and B is also node, and we have capacity 2, 2. So 2 is our capacity and 2, this 2 is our flow. So means that so flow of an edge, that is 2, which is equals to capacity of an edge, that is 2. So 2 equals to 2, this is true. So we can call this edge A, B. This edge is a saturated edge. Saturated edge. So this can be called as a saturated edge. Okay. So we also have the formula for saturated edge, like F flow of edge equals to capacity of edge. So remember this formula, flow of edge equals to capacity of edge. So you also need to write here. Let me write clearly. So here write equals to E, that is flow through edge equals to capacity of edge. So you can write this formula over here. So what is unsaturated edge? So an edge is unsaturated if the flow on it is less than its capacity, that is there is still room for additional flow. Means that we can write mathematically as flow of an edge is less than or equals to capacity of an edge, that is flow through is less than capacity of is, right? So you need to write these things, saturated. And so in the given question they have asked to write down the saturated and unsaturated. So as we have discussed the theory of saturated, means our flow through is must be equals to capacity of is. That means it is a saturated is, means this A and B can be called as saturated, and these are same, right? So 2 and 2. So C and D is a saturated is. So saturated is. So this is 3 and 3. So both are equal. So we can call it as saturated is. So what does it mean? What does it mean? So 4 comma 3. So this flow through this is less than the capacity. So 3 is less than 4, which means unsaturated. Okay. So this is one is flow. I already told you this first one is capacity and second one is flow. So capacity value must be greater than or equals to this flow value. So in here yes to a our value is 5, which is greater than 3. So 5 is capacity and 3 is flow. So likewise this 6 is capacity and 1 is flow. So as per the definition of unsaturated, so unsaturated can be defined as flow through is less than the capacity of is. So this is flow less than 6. So this A to D is unsaturated. So this is unsaturated. Okay, unsaturated. So likewise C to A. So C to A is 1 is your flow and 5 is your capacity. So this is also unsaturated. So later on you will find out on and write down which one is saturated is and which one is unsaturated is. Later on we will discuss every detail. So move on to the next part, F augmenting path and S to D cut. Okay. If you enjoyed this video and want to see more on variety of topics, please hit the subscribe button. I am always creating new content on C programming, operating system, Java programming, PHP programming, HTML, CSS and JavaScript, computer architecture and many more of IT subjects. Please do subscribe. So what is F augmenting path? So an F augmenting path is a path from the source to sink in a residual graph where each edge has positive residual capacity. Finding and the purpose of F augmenting path is to find an F augmenting path allows us to increase the flow from the source to sink. So source and sink means the destination. The existence of such a path indicates that the current flow is not maximum and can be augmented. So augmented path can be our this from S to A to B and B to D. So this can be our augment. So we will find out the path, we will find out the minimum value from the given graph, which means bottleneck capacity. So we have a augmenting path that is S A B D and the bottleneck capacity will be 3. So 3 is the flow, minimum flow. So here we have a minimum flow. Likewise, if I move from S C D D and my bottleneck capacity will be 2. So this flow is 2. So I can flow the minimum from S to C, C to D and D to the destination, or this is the sink, right? So you will find out the augmenting path from source to the destination, from S to this D. And what is S to D cut? S to D cut, source to destination cut, is a partition of the vertices of the graph into two disjoint subset. That means S and D. S and D such that the source node belongs to S. Okay, I will put it down here. So such that the source node belongs to S and the sink node belongs to D. So capacity of the cut means that the sum of the capacity of edge that cross from S to D. So we will put the cut with S to D, like you need to cut like this. Okay, so if I cut this, so this will become yes, A and C becomes the sink, that is S part. Okay, and this is a cut, right? This is a cut, and B, D and D. So B, small d, and the destination D will be the, sorry, this one is not sink, this one is source. So this one is source, and B, D, D, this one is sink, right? That is D, destination. So I want to say that if you cut the source and destination, the value of source and the sink part will be same. Means clearly I will explain here. So let us discuss this here. So if I cut this way, this way, this is the cut, S to D cut, and this source have this part, this and this, right? So you need to write S, A and C, source, and we have a destination or sink, that is D, that is B, that is D and D, right? This is a source and this is a destination or sink. So find out the flow, find out the flow of every part that is incoming, that are incoming from source to destination. So this is our outgoing edge. So observe this path, that is 2, and observe this value, that is flow value, that is 1. So 2 plus 1 plus, and observe this value, flow value, that is 3. So clearly you have seen that we have cut from this part, and from source to destination we have edge, this outgoing, and this outgoing. So outgoing from source to destination, assume like a from source to destination. So you need to write only flow value, that is 3 plus 1 plus 2, that is 2 plus 1 3, 3 plus 3 equals to 6, right? So then move on to the destination path. So this is the sink part. So observe incoming. So write down the incoming flow. That means this is incoming and this is incoming. Flow value is 3 and flow value is 3. So 3 plus 3 will also be 6. So this 6 must be equals to 6. So this 6 will be our cut value S to D, right? The S to D cut, as we have discussed earlier. So you can write the definition of S to cut: vertices into two disjoint groups. One group will contain the source and another group will contains the sink, that is destination, right? So you can write these 2 points in the S to D cut. So now let us jump on to the calculation part, that is calculate the slack of each edge, write down the saturated and unsaturated edge and find the S to D cuts using following graph. So we need to follow this graph to find the slack of edge and find the saturated edge, unsaturated, and find the S to D cuts. And we need to cut the graph into two parts, and one is source and another one is destination, right? So now jump on to the numerical part, that is calculate the slack of every edge, right? So first of all we need to write down the every edge. S to A is one edge, S to C is another edge, C to A is another edge, A to D, A to B, B to capital D, small d to capital D. These all are the edge and we need to calculate slack of each edge. Okay, so first write down the point wise. So S B, then S C, these are A's we are writing from the given question. A B, another one C A, okay, C A, likewise A D, B D, D D, okay. First of all you need to write all these edges, then the C to A, then we have another is A to D and C to D, and we have another is B to capital D, and we have D to capital D. Okay, now find the slack. So I already show you the formula of slack. So we have the formula slack equals to capacity minus flow. So write down the formula slack equals to capacity minus flow. So what is the capacity of S to B is, and what will be the flow of S to B? We need to write down it from over here. So S to A is 5 is capacity and 3 is age. So write down here 5 minus 3 equals to 2 slack. So this is our formula. So likewise S to C, look the graph S2C. S2C, this is our 4 is our 4 is our capacity and 3 is our flow. So 4 minus 3 will be 1. So in the S2C is we have a 1 slack. So write down this 4 minus 3 equals to 1 slack. So for A to B we have 3 minus 3, that is 0 slack. Let us see A to B. Let us see A to B. A to B, we have 3 comma 3. So first 3 means capacity, which is always greater than equals to flow, that is this is flow and this is capacity. So 3 minus 3 will be 0. So the A's, that is A to B, will have 0 slack. So write it down all the remaining part. So C to A. So C to A means we have 5 minus 1 equals to 4 slack. And A to D. A to D means 6 minus 1 equals to 5 slack. C to D means 2 minus 2 equals to 0 slack. B to D, 4 minus 3 equals to 1 slack. And D to D, that is 3 minus 3 equals to 0 slack. So we have put all the capacity value and all the flow value of the particular edge, and we need to subtract from capacity minus flow, and you will get the value of slack. Okay, so this is the final answer for calculating the slack. So now move on to the next part. Write down saturated and unsaturated edge. I already told you in the first part while I am beginning or while I am starting the definition of saturated and unsaturated edge. So saturated edge can be defined as the flow through edge equals to the capacity of an edge. So this 3 and 3 are same, then we can call this edge is a saturated edge, and this 1 is a flow through edge is less than capacity of edge, that means this is unsaturated edge. So here we have A, B edge are saturated, C, D is saturated, and D and capital D is saturated. So remaining all are unsaturated. So here we will find the saturated edge. So calculate. So we have another part. So calculate the saturated and unsaturated. Is okay. So first of all, write down every saturated edge. Saturated edge. So we have the saturated edge in the given question. This A, B, C, D, 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 A, B, C, D, 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 which all are same. A, B, here write down A comma B is an edge. Then you also need to write C comma D is another edge, that is saturated edge, and last one we have small d to capital D, these are saturated, and remaining all are unsaturated. Saturated means we have a formula that F flow of is equals to capacity of is. So you need to remember this formula. So an unsaturated means flow of is less than capacity of is. So this is the formula for unsaturated, for finding the saturated. So write down the remaining part, that is S to A, this is unsaturated, and S to C, this is unsaturated. Likewise A to D is unsaturated, and we have B and D is a is which is also unsaturated. So these edges are unsaturated and these edges are saturated. So these all are saturated and these are unsaturated. So this part is also completed. So move on to the next part, chord part. So find S to D chords using following graphs. So we need to place chord, always place so chord means, as already told you, vertices can be grouped into two disjoint. That means one group will contain the source, one group will contain the source part, and another group contain the destination part. So if I cut this is a source, this part is a source, and this part is a destination, and this part is a destination. So if I so write it in clear way. Okay, so S to D cut. So another part is calculate or find S to D cut. So I have cut S A C as one part and B D and capital D is another part. So this is source part and this is destination part, right? So observe carefully, this outgoing is from A, outgoing is from A to D, and outgoing is from C to D. Write the flow value only, that is 3 1 and 2 for the source part, and for the destination part we have 3 and 3. So 3 plus 3 equals to 6. So here 3 plus 1 plus 2 also be 6. So 6 value flow is incoming from source and outgoing incoming from from source. 6 is the value of the source and 6 is the destination value, that is 3 plus 3 is 6. So these two value must be same, so 6 and 6. So we can write this 2 plus 1 plus 3 equals to 6 and 3 plus 3 equals to 6, right? This. So this is our cut. So simply in the exam you can write S to D cut could be S equals to, you can write S equals to SAC and D equals to BD. So S equals to source, that is SAC. and destination, that is destination means sink, B D D, right? And finally you also need to write theoretically that the capacity of this cot would be the sum of the capacity of age from S to D, that is 2 plus 1 plus 3 equals to 6. This is your answer, right? So you no need to write the part, that is this part, destination 3 plus 3, or you can write this 3 plus 3. So this much for today. So hope you understand the how transportation network works and how we need to calculate the saturated and unsaturated age, and how we need to calculate the slack of each age, and how to find the S to D cut. So for S to D cut, so cut from in between, separate the one part as a source part and another as a destination part. So cut this like, and write the flow value, that is 3 1 2, and add it, and you will get the value, that is 6, and this is your answer. Okay, thank you so much for today. Hope you will enjoy my video and do practice. Subscribe my channel, comment, like, and share with your friends. Okay, see you. Bye. Thank you so much.